Okay, so we have a couple equations up here. Again, not set up for graphing. How do we know it's not ready for graphing? Very good. It's not solved for y equals mx plus b. How do we know it's not ready for substitution? Okay, because I don't have, that's more elimination right away. But I don't have a y by itself or the x by itself. So we're ready to say, okay, yep, since I was teaching elimination, it's probably elimination. We can eliminate x's or y's. Somebody choose a variable. What do we want to eliminate, x or y?
Y.
Sure. We choose y. I agree. So then if I look at the top equation, I have a positive 3y. Therefore, what do I need on the bottom equation to eliminate them out? Negative 3y. So that means I need a negative 3 in front of that y, correct? All right. If somebody were to say x's, would it have been wrong? No. If you wanted to eliminate x, you can. You would just have to have, this is already negative, you would want a positive 3x. But you chose y, and I'm good with that. So, I need to have what in front of this y again? To eliminate? Negative. Very good. And negative 3 is what I heard you say. Thank you.
Yeah.
All right, so negative 3. And we multiply everything in that equation by negative 3. So we get a new equation off to the side. Negative 3 times negative x, positive 3x. Negative 3 times positive y, negative 3y, equals negative 3 times positive 3, negative 9. I'm not changing the top equation, am I? No. So I'm just going to rewrite it so our work is all nice and neat. So negative 3x, positive 3y equals 4. All right, so it looks like we have a negative 3x positive. Oh, we're ready to add or subtract, right? We're ready to add, which is eliminating. All right. So, negative 3x, positive 3x, what happens there? They cancel out. You told me we were canceling out y's, which those cancel out as well, right? Well, if they cancel out, what is really negative 3 plus 3? 0. Same thing as a positive 3, negative 3 when we look at y's. It's 0, correct? So they're canceling out to give me 0. But then over here, what do we get? Negative 5. Remember how we had 3 options of solutions? I don't know if you remember putting that in your notes or not, but we put this little extra thing in our notes. Well, let's see here. Remember how we had these 3 options where we had a no solution, a 1 solution, and infinitely many? Right? There were 3 options we have. Most of them do stay in that middle category where it's 1 solution where we have an x comma y. That's what we've had so far, correct? Yeah. Well, this is a special one. So if we go back to what we have up here and say, okay, let's use our reasoning skills here. Is that a true statement or a false statement when I say 0 equals negative 5? False, right? All right, so this is a false statement. If I think about no solution or infinitely many, which would you think kind of fits with the false statement? A no solution. Very good. Okay, so if we were to graph those 2 beginning equations, and we have technically a no solution, they would graph to be parallel lines. Okay, so this is a special case this right here, if you end up with false, it is going to be a no solution. If you were to end up with a true statement, say for example, it ended up being 0 equals 0, or maybe it was -5 equals -5. Those are true statements, correct? Right? If it was this or this, it's true. So that would be the other case we have, which is infinitely many. Okay? So if it goes where it's 0 equals 0 or a -5 equals negative, it's a true statement, then it's infinitely many. If it's a false statement, then it's a no solution. And that happens sometimes, not very often. Okay? So these are our special cases. But this right here is our answer. Okay? So that does happen. Now, is it always going to be where we only have to multiply one equation? Not always. Okay? So we are in Algebra 2. It does get a little bit more work involved. Okay? Any questions here? So again, false statements are a no solution. True statements would be the infinitely many. Most of them stay in that category of an x comma y. All right? All right, let's look at another example which is not from that worksheet 3. Not set up for substitution. So if we think about elimination, it's not truly set up for elimination. So again, we have to think about what makes something be set up for elimination. The positive, negative, same number in front. So if I think about x's, what's a number that 5 and 2 both go into? 10. We could use a positive, negative 10x. If I think about my y's, I have it an 8 and a 7 in front. What's a number that both 7 and 8 go into? 56. So I could choose either x or y again. It does not matter. So again, you may think differently than your neighbor. But for me, I would probably choose x just because smaller numbers. But we could still do y. Do we want to do x or do we want to do y?
X.
X, I would agree. Another reason why I would probably choose x is because I have a negative and I already have the positive. If I were to do the y's, I have to make one of them be positive. So I have to think a little bit harder on that. But we choose our x. It's good enough. You said 10. So what do I have to multiply that -5 by to get -10? 2. So I'm multiplying the top equation by 2. And we're going to write the new equations over here. 2 times -5x is really what? Did I do good math? 2 times -8y. Thank you. And equals 2 times 17. Is that good math? All right. The bottom, we want a positive 10 there. So we have to multiply the bottom equation by what? 5. Very good. All All right, so 5 times 2x really gives me 5 times negative 7y. And 5 times negative 17, and I'm not a human calculator, so if we need to punch that in, could somebody maybe for me? Negative 85. Negative 85? Thank you. All right. Are we ready to add them together so we can eliminate? You bet, because we have a negative 10x and a positive 10x, we're ready to add them together. All right, those eliminate, giving me 0x, which cancels them out, gets rid of them. Negative, 51, yeah? Thank you. Like I said, I am not a human calculator, just a math teacher. And then negative 50, oh, I like. That worked out nice, didn't it? Because now we're going to divide by what? Dividing both sides by negative 51, we get a nice, easy answer of 1. I now know that this is one of those one solution answers. So we take that y, and what do we do to solve for x? You got it, you got it. Do we want to go into, oh, we're going into y this time. Top y or bottom y?
Bottom.
Sure. I hear the bottom y. So we're taking that y, still have a 2x, minus 7 times, instead of y, we substitute that 1 in. And we do our math. So multiplying first gives me 2x minus 7 equals negative 17. Adding 7. $2x equals negative 10. Did I do good math there? And then dividing by 2. How do we write our answer? X, Y, Z alphabetically. So therefore we have x and y, so negative 5, 1. How do I know if we have a correct answer? Because I always hear students say, did I do this right? Do I have a correct answer? Is this correct? How do I know? Yeah, you could take this x and this y, and you could substitute it back into the equations at the original starting point and see if it holds true for both of those equations. Which I'm going to think you're helping me out with my math, so I'm going to say we're good. All right. That's the hardest to get. So now if I think about it, some people always, are thinking to themselves while we're doing math, which is good. Am I always probably just going to multiply the two numbers together? Like we took this one times a 5 and we took that one times a 2? Yeah. Or if you were choosing your y's, you would multiply the bottom one by maybe the negative 8, the top one by the positive 7. Okay? That's usually what you're doing if it's not set up where you just multiply one equation. All right, questions? I do have a worksheet number 2. So number 3, you can keep that. Number 3, you can keep that. That was a little practice over the weekend. This worksheet number 2 has some circle stuff on it. Tissues are going to be behind the door. It's just for the paper. Yeah. Okay. This is algebra 2, 1B. Oh, you need one more. Sorry. Thank you. Keeping me on my toes. All right. I do have some circled ones. It's not that those are the ones I'm going to assign. Look at them a little closer. Why do you suppose I circled those? Those of us that have the worksheet in our hands. Yes, very good. If you look at your worksheet number 2 that I'm handing out right now, okay, I circled them for a reason. They're set up for substitution. All right? Number 2 worksheet is set up for substitution on 1 through 6. Well, I didn't circle 7 through 10, so what do you suppose you have to use on those? Elimination. Okay? So, I'm assigning 1 through 10 as an assignment. On the back, there are 10 more problems. You only need to do 5. Okay? You only need to do 5 on the back. I don't care which 5 you choose. None of them are really circled, so that means you're probably doing elimination, right? On the back. I won't help you out all the time, but this was kind of set up that way. So again, 1 through 10, yes, all of those on the front. On the back, you get to choose how many? 5. Somebody might say, well, what if I get overzealous and I want to do all of them? Can I get extra credit? Yes. Okay, so again, 1 through 10, yes, you have to do the first 10 on the front. You choose 5 on the back, that's part of your assignment, so 15 is part of that's your assignment. If you do all of them on the back, it's extra credit. Okay? Once in a while, I'll kind of do that extra credit business if you want it. Okay? Again, remember, where do I save all my stuff? Canvas, modules. And I already have videos there. Did I show your class what the videos look like? Was it you that asked? Yes. And I'm going to, like I said, I still haven't edited them, but I'm going to try to put video and then the okay. Because then it'd be easier to remember. Okay? All right. And we get out of here. I don't know the normal block schedule now. I think I printed some, so I'm going to go look. Lunches, I think I'm going to leave that for your homeroom to tell you, so we go to homeroom after this.
I'm not finished this worksheet. Is this the worksheet?
That's not even.
Don't even.
And she did it. That's what it goes.
Bro, I didn't even do it. I'm kind of thankful.
Yeah. My phone number. I got a notification.
And you did it.
They don't want to do I don't want to.
I know.
What do you got? What do you know?
Okay, lunch is really confusing, so I am gonna put it up here. We get out of here at 9:15, just so you know. 9:15. Lunch looks really confusing, and you could switch from A day to B day, so I am gonna put it up here. Did everybody get a worksheet number 2 first, though?
Yeah.
All right. Okay. Again, remember you look at your schedule. Today's a B day, so we would want to look at the third block B. Third block B. It goes by teachers, you guys, so it is definitely a little more confusing than normal. I'm going to show you this. I don't know that I truly understand it quite yet either.